Hello everyone, today in this video we are not going to talk about Ohm but we are going to talk about Coulomb. So after this video you should be able to state Coulomb's law. It's not Coulomb, it's Coulomb's, and you have to define 1 Coulomb using Coulomb's law and apply Coulomb's law to solve numericals. So we already know two like charges repel each other and two unlike charges attract each other. So to repel or to attract we need force, and when we are talking about force we have to tell how much force is there between two charges. So in order to know how much force we need the help of Mr. Coulomb or Coulomb. So using Coulomb's law we can find the magnitude of force between two charges. So now let's understand the Coulomb's law. Suppose we have 2 point charges Q1 and Q2, and suppose the distance between them is R. So according to Mr. Coulomb, the force between these two charges is directly proportional to the product of two charges, and the force is inversely proportional to the square of the distance between them. That means force depends on magnitude of charges and distance between them. So if you increase the charges, force will also increase, and if you increase the distance, the force will decrease because it's inversely proportional. Now according to Coulomb's law, force between two charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. So according to first condition I can write this, according to second condition I can write this. So if you combine them you will get this. F is proportional to Q1 Q2 divided by R square. So now I'll remove this proportionality sign with a constant K. Now this is the mathematical form of Coulomb's law, and this K is a constant called electrostatic force constant, and the value of this K depends on the nature of medium between the charges. Different medium, different value of K. So now let us understand more about the electrostatic force constant. So let's find the unit first. So this is the Coulomb's law. Now I can take this R square up and Q1 Q2 down. You will get K is equal to FR square by Q1 Q2. And now unit of K. So to find the unit of K, I'll write the unit of this side. So for force it's Newton, and for distance it's meter square, and for charge it's Coulomb. So there are two charges, so Coulomb square. So you can write Newton meter square per Coulomb square. Now let's find the dimension. To find the dimension, I'll write the dimension of right hand side. So for force it is m1 l1 t minus 2, and this is r, that is distance, that will be l square, and for charge the dimension is 80 because we have two charges, so I'll write 80 square. So now the final dimension will be m1 l3 t minus 4 a minus 2, and for vacuum or air the value of K is 9 into 10 to the power 10 Newton meter square per Coulomb square. Now let's apply Coulomb's law to define 1 Coulomb. So according to Mr. Coulomb, force is K Q1 Q2 by R square. Now if you put the value of K, and if you put Q1 is equal to Q2 is equal to 1 Coulomb, because we are defining 1 Coulomb, then if you put R is equal to 1 meter, then your force will be like this, and your force will be 9 into 10 to the power 10 Newton. So this is the definition. Now let me explain the definition. Suppose you have vacuum, and if you are keeping two equal charges at a distance of 1 meter, and if they repel each other with a force of 9 into 10 to the power 10, then these two charges are 1 Coulomb. So this is the definition of 1 Coulomb. Next is permittivity of free space. And let's see what is permittivity. So according to Coulomb's law we can write this, and Our K is constant called electrostatic force constant, and this K can be further written as 1 by 4 pi epsilon naught, and this epsilon naught is called permittivity of free space. And the permittivity means it is the property of a medium to allow the two charges to interact. So this permittivity will determine the force between them. So if you have two charges, the force between them in air is suppose 1 Newton. Then if you put them in water, then that time it will not be 1 Newton, because the permittivity of water will be different. So according to permittivity, there will be a force. So you are saying how much a medium is allowing them to exert force on each other. So this is the new form of Coulomb's law. Instead of K, we are writing 1 by 4 pi epsilon naught. So in some cases we are using this, and in some cases we are using this. So now you can see, if you take the permittivity this side, you are left with this. Now let's find the unit of permittivity. So for this, you have to put the unit of this side. So this is Coulomb and Coulomb square, and this is force Newton, and this is distance, that is meter square, and 4 pi is a number, so it does not have any unit. So unit is Coulomb square per Newton per meter square. So it is just opposite to that of K. For K it was Newton meter square per Coulomb square, and it is Coulomb square per Newton per meter square. Now let's find the dimension. So to find the dimension, I have to write the dimension of charge, that is 80 square, and down there is force, so m1 l1 t minus 2, and this is distance l2. So if you solve, you will get m minus 1 l minus 3 t4 a2, and the value of permittivity of free space. So for free space, the value of epsilon is this much. Now let's note down the important points. So Coulomb force is a central force, so it acts along the line joining center of two charges. So Coulomb force is long range force, that means the force will act even if the distance between two charges is very large, and there are some limitations. So this law is applicable only for point charges at rest. So if the two charges are at rest, then only we can use Coulomb's law. Otherwise, if they start flowing, we have to consider electromagnetic force, and this law is not applicable for the distance which is less than 10 to the power minus 15 meter, because if the distance between two charges is less than 10 to the power minus 15, then nuclear force will come into play and electrostatic force will not be there. So you can see inside the nucleus two positive charges are staying together, because inside the nucleus there is no Coulomb force or electrostatic force, there are only nuclear force. So for short distance we cannot use this formula. Now let's see how to find the nature of force. Nature of force means whether it's attractive or repulsive. So according to Coulomb's law, force is directly proportional to product of two charges. Now let's see what happens for like charges. So for like charges, Q1 can be positive or Q2 can be positive, and both can be negative. Now according to this, if you multiply positive, you will get positive out here, and out here if you multiply Q1 and Q2, that is negative into negative is positive. So for like charges, forces are always positive, and if the charges are unlike charges, suppose one is positive, another is negative, then if you multiply positive into negative, you will get negative. So the conclusion is, if force between two charges is positive, then force is repulsive, and if force between two charges is negative, then the force between them is attractive. Or in another form, you can write, if F is greater than 0, force is repulsive, and if force is less than 0, that is negative, then force is attractive. So these 2 points are important. Now we will apply Coulomb's law to solve some problems. So calculate the force between two alpha particles kept at a distance of 0.02 millimeter in air. So out here Q1 and Q2 is given, that is 2e. So alpha particle means nucleus of helium. So helium has 2 protons, so this is 2e. E means basic charge, it can be charge of electron or charge of proton, and R is 0.02 millimeter. So we have to convert this into SI unit, that is 0.02. Milli means 10 to the power minus 3. So because of this 2 decimal point, I will have minus 2, so it will be 2 into 10 to the power minus 5 meter. Now this is Coulomb's law. Now let's put the value. Now this is 4E square. Now I'll put the value of K and value of E, that is 1.6 into 10 to the power minus 19, and R is this much. So if you square this, you'll get this 4 and 4 get cancelled, so you are left with 9 into 2.56, and this 10 will go up and it will become positive. Now you are left with this. If you solve this further, out here minus 38, I am adding 9 and 10, so it will come as positive 19. So last answer is 33.04 into 10 to the power minus 19 Newton. So now we can shift this point out here to write it in the standard form. So this is the standard form, and you are getting 110 out here, so it will be minus 18 Newton. So this is the total force between two alpha particle kept at a distance of 0.02 millimeter in air. Now this is another question, you can try it by yourself. Calculate the force between two alpha particles separated by a distance of 3.2 into 10 to the power minus 15 meter in air. So out here it is given in SI unit. You can do it by yourself the same way I have done the previous question. So out here electrostatic force of repulsion between two equal positive charges is given. That means force is given and distance is given. You have to calculate the charge, and they are saying two equal positive charge, so you can use Q1 is equal to Q2 is equal to Q, and the distance between them is 5 Armstrong. Armstrong means 10 to the power minus 10 meter, so 5 into 10 to the power minus 10 meter. So now you can easily calculate Q because force is given and distance is given. So this is the next question. It is saying calculate the distance between two protons such that the electrical force between them is equal to the weight of the either. So mass of the proton is given, so it is saying the force is equal to the weight of one of the proton. So we know the weight is mg, and m is already given, mass is this, so g is acceleration due to gravity, so we can find the weight, and it is saying weight is equal to the force. So you can write mg is equal to force is this. So from here you can find this distance. So answer is already given, so you may not find the exact answer like this. So if it is coming near to this, it is fine. So now next question, a free pith ball. Pith ball means a small ball made out of thermocol of 8 gram carries a positive charge of this much. What must be the nature and the magnitude of the charge that should be given to second pith ball fixed 5 cm vertically below the former pith ball so that the upper pith ball is stationary? It is saying we have this charge out here and the force is downward force, the weight, and we have to keep another charge down so that this remains floated in air. So according to this there will be downward force, so this should give upward force to this, so that means there should be repulsion between these two, so this should be positive. So we know electrostatic force between them is Fk Q1 Q2 by R square, and according to this question these two forces must be equal so that this charge remain stationary or floating. So we have to have this condition, this downward force should be equal to upward force. So you can find the value of the second charge. So this is the answer. You should get 4.4 into 10 to the power minus 7 Coulomb for this charge. So I think this is the end of the video. I would love to hear your opinion about my video, so please write something in the comment section. Please don't forget to like the video. Yeah, you can like it now, and please subscribe my channel if you are new to this channel, and you can share it to your friends. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.